Hi, my name is Jane Ginn, and I'm with the Cyber Threat Intelligence Network. Today, I'll be walking you through at a very high level the new STIX 2.1 standard. Thank you for joining us.
Hi all, it's April 6, 2020, and we're about 3 weeks into having just finalized the STIX 2.1 Committee Specification 01, specification that the Cyber Threat Intelligence Technical Committee has been working on for over 5 years. So I offered to give this presentation as a summary of what we have done over the last 5 years. And I just want to point out that this is and will be part of an ongoing webinar series that I'll be offering through CTIN. It's Traffic Light Protocol Green, and it is covered under a Creative Commons Attribution Share Alike license. So, global machine-readable threat intelligence. That's really what the objective of the Cyber Threat Intelligence Technical Committee was all about. And so today, what we're mainly going to be talking about is that CTI ecosystem. But a wonderful thing about what's happened with STIX 2.0 and 2.1 is that although the folks that were driving the specification were primarily software engineers and software programmers and data analysts and architects, they also recognized that what we were building also had to be human readable as well. And to satisfy that group of stakeholders, we've really expanded the 2.1 data model to accommodate the needs of the analyst community. I'll talk a little bit about that as we drill down into the standard. So just a little bit of history. You all probably have been receiving STIX 1.0 or 1.1 data feeds through some of your various platforms and your threat intelligence platforms, your SIEMs. The earlier version was funded by Department of Homeland Security and developed by MITRE and a very broad international community that participated mainly on a listserv in support of MITRE's development. It was built out as an XML serialization, and what we found is that because there were so many different people involved and they had so many different needs, that the way it was originally configured, there was a lot of customization. And because of that, it wasn't as interoperable as we had hoped it would be. So DHS decided to transfer the intellectual property and to an international standards body, and the standards body that was chosen was OASIS. So on Wednesday, May 20th of 2015, all of the IP was transferred over to OASIS and the technical committee was formed. We made a decision at that time as a technical committee that we were going to move towards a JSON serialization as the mandatory to implement because the broader community was more supportive of JSON. It was a lighter language serialization and was much better performing at scale, which is what we really needed to be. And we also realized that by doing this, it was not backward compatible. So we essentially started afresh on that date. These are some of the organizations that have been members of the technical committee over this 5-year period. We've had contributions from almost 300 people and over 70 organizations during that time. And as you can see, this represents critical infrastructure companies, manufacturing, government, academia, a lot of the IT companies that are in the threat intelligence space, the banks, telecommunications, intelligence agencies. So it was a very, very broad group that worked together to create this specification that I'm going through right now. So here's the public website, and I serve as the secretary of the technical committee. We have two co-chairs, Richard Struess, who was originally at Department of Homeland Security and then moved over to MITRE, and Trey Darley, who's with the Belgium CERT. We have a number of different subcommittees, and I'll talk a little bit about those as we move forward. I have the URL here. I'll create this as a PDF and I'll share it in the Slack channel. And if there are those here on the call that are not in the Slack channel and want to be, please reach out to me after this and I'll make sure you get onboarded. And or if you don't want to be on the Slack channel, just send me an email and I'll send you an email with the PDF. So our STIX subcommittee originally had a kind of a sister subcommittee called the Cyber Observables Subcommittee, which was how we originally envisioned incorporating all of the CyBox objects, or if this was a standard that had originally been developed by MITRE. CyBox stands for Cyber Observables, and that is really a representation of the very granular data objects that we were looking at. But as we moved forward, first with STIX 2.0 and now with 2.1, we realized that it didn't make sense to keep CyBox as a separate standard. So we completely subsumed CyBox into the STIX standard, and we now are trying to kind of flush out all those original CyBox objects. There were, I think, 72 in the CyBox standard. We've got about 20 or 26 or so that we've already translated into the STIX standard. So as we move forward with 2.2 and beyond, we'll be moving more and more of those CyBox objects into STIX. As I mentioned, we finalized the STIX 2.1 CSO on March 20th, 2020. And we also have a parallel subcommittee, TAXI, which is the transport mechanism for the STIX data objects. And that was finalized as a 2.1 CS01 on January 27th, 2020. We have a marketing subcommittee, and very importantly, we have an interoperability subcommittee. And at the end of this presentation, I'll talk about why that's so important. So let's drill down into what STIX is all about. But before I go there, I'll just open it up. Does anyone have any questions or comments at this point? So hearing none, I will proceed ahead. So what we were really looking for was a common ontology that could be used across all of those different stakeholders. Many of the companies that were directly involved in the standard, but really stakeholders representing the broader global community as well. And so we developed this originally, the 1.2 data model, as a sort of a bare bones representation of what could be accomplished if you were sharing information about various features of an attack pattern or an indicator that raised an alert on a system. What you're looking at here is an edge and node type model. The STIX design was always, from the beginning, envisioned as a graph data model, and graph data models are represented as edge and node type designs like this. The edges represent the relationships, or the lines here on the graph, and the nodes represents the data objects. And today we'll be primarily talking about the data objects, but we've added something in 2.1 that I think is very important with respect to relationships, and I'll get to that in a little bit. So what did we learn from version 1.x? Well, I've mentioned before JSON, not XML. It's preferred by developers and it was easier to understand. We wanted simplicity and clarity. What we found in the various implementations among the various companies that were involved and the programmers that were trying to work with it was that the original specification was too ambiguous in many ways, and especially in the normative language. That's the language, the kind of descriptive language that supplements the specific descriptions of the properties in each of the data objects. So we wanted more standardization. We wanted it to be very pragmatic, very much oriented toward real business use cases. We wanted the one standard, so we merged SciBox into STIX, and we realized that we needed relationships as first-class objects. That is, we needed others in the community to be able to contribute to what an originator or a producer of a data object developed or shared with their broader community. And that's why we've, in the data model, we've elevated relationships as first-class objects. And then we also wanted to leverage existing HTTP features so it was easier to use with existing tools in the community. Some of our design principles were that it was vendor-driven, understandable by humans, but designed for machines. There should be one way of doing any one thing. We wanted to limit optionality whenever feasible, and we wanted to avoid reinventing the wheels. So we referenced existing standards whenever possible. And you'll notice here I have in very large font interoperability. That was the key driver throughout all of the discussions over the last 5 years. And just to give you a sense of how intense it has been to build this standard, we were having weekly working sessions and monthly full TC sessions for 4 of those 5 years. We've now dropped the working sessions down to 1 or 2 a month, and our monthly call down to 1 a month. So it's, it's a very engaged group, and it was very, very interactive. The net result is that 2.1 it should be easier to implement, easier to consume, and more foolproof to the end user. A few things I want to point out. We added a patterning language, which is embedded in the indicator STIX data object, or it's actually a STIX Domain Object, SDO. We also added a citing relationship object. So this represents our normal relationship object between any STIX cyber observable, formerly known as SciBox, or an SDO STIX domain object. But we now have added this very interesting citing object, which allows us to do a quantitative count, and it has a special relationship to one of the STIX domain objects. And then very importantly for interoperability, we've added the self-certification program. And these are the seals that are up on the OASIS website that gives the details on the self-certification program. So let's go over some of, yes.
Just briefly, are you going to go into citings a little bit more? Or shall I hold off my questions on that?
Yes, I do have a slide on citings.
Good. Yeah, it's particularly relevant to network traffic analysis. Anything in a SIM, anything collected on the internal environment that's matched against the external environment is a citing. So I've been looking at how citings are processed. So I'm looking forward to that slide. Thanks.
Okay, yeah. So Yeah, we did add some other things that made it even more expressive, more responsive to the international community, and more useful for human analysts. We added this language meta object represented by this icon. We added 5 additional STIX domain objects that provide significant support for human analysts. We significantly flushed out malware, and we added new malware analysis data object. Malware in 2.0, which was finalized in 2017, was really just a stub object because we couldn't get agreement among all of the different stakeholders on how we really wanted to deal with the malware object. Because if you do cyber threat analysis and you use tools like hybrid analysis and VirusTotal, you know that you have both the static analysis and the behavioral analysis that you need to look at. And there are a lot of data fields. So what we decided to do for malware is that the malware data object now represents either an instance of malware or a malware family. And most of our properties on that data object stem from static analysis, whereas the malware analysis tool or data object is really more geared toward behavioral analysis. This is a very, very important feature that we added, and that is we added a confidence property to most of the STIX domain objects, which gives the user community a way of registering their confidence in the reliability of the data source, the reliability of interpretation of the data, the level of confidence that they have in the data source. And so it makes the language much more expressive. And then I mentioned earlier that we have relationships between SCOs and SDOs. I hear some sound in the background. Is someone trying to say something?
Can you hear me?
Yeah, now I'm hearing you.
As I say, was there some idea there for being able to leverage supervised or semi-supervised learning with the confidence property? Because that there's a level with training data sets for deep learning models utilizing a confidence property. And so was that like a secondary thing, or is that am I bringing this up for the first time?
No, actually there was some discussion on that, and I think that idea was largely what drove the technical committee to add that as a required property to most of the STIX domain objects, because so many of the companies are, moving into machine learning.
Okay, cool.
So moving on, I'm not going to go through each of these. There are 18 STIX domain objects, but I am going to point out a few things as we move along. And I'll also provide this to you. I also sent out the copy of the specification earlier, or Greg sent it out, and then I also put it up on Slack. So what you'll notice here is that for the most part, these are in alphabetical order. And I say for the most part, I've extracted the data objects that are specific to analysts and put them all on a slide of their own, because I want to kind of give them a little bit of special treatment, because what CTIN is trying to provide to Reprivita, and which is, that whole cadre of analysts to support the Reprivita tooling. So with respect to what we're seeing here, we're seeing the various data objects that fall into various categories. Attack pattern could be characterized as a part of an adversary category, along with campaign and threat actor. Course of action is something that could be categorized as being part of incident response, you'll notice if you're familiar with STIX 1.0 or 1.1, we did have an incident object in that data model. We never could get agreement on it in the CTI TC, so that is slated for the next version of STIX 2.2. But ultimately, we do want to capture that incident information, and that would be categorized in here with course of action. We have identity, and then indicator is really a very important kind of central theme in the whole STIX data model. It stems from the original nomenclature that was developed by Mandiant. Mandiant's now part of FireEye. They originally called the observables indicators of compromise, or IOCs, and you see that acronym a lot still. But I think as the community moves more and more towards adopting STIX 2.1, we're going to hear the acronym cyber observables more and more, because what we really want to do is catch what's going on before there's a compromise. So we want to take the compromise out of the, even mentally out of the notion of it. And then you'll see that I've identified here a very important feature of indicator, and that is that it's the patterning language, which is a new, we call it a language that we developed in the CTI TC. It is specific to the indicator, and it's a required property in indicator. I'll talk a little bit more about that later. We have infrastructure, which describes systems, software, services, and associated physical or virtual resources. And depending on how the producer is using the data object to express what's happening, it can, the data object can convey whether or not it represents a benign infrastructure that has been taken over by a threat actor, or a malicious infrastructure. We have intrusion set, which is also part of that category of adversary activities nodes. This is typically used in the context of advanced persistent threats, where you see multiple campaigns over time, or APT groups that are sharing a malicious infrastructure. And so intrusion set is able to convey that those common properties across time. We've added a location STIX domain object, which allows us to include lat-long and cities and regions, which is really important as you start to sort of drill down into attribution if you're going there. And then I talked a little earlier about malware and how we're beginning to use malware and differentiate that from malware analysis. We also have this observed data, which we're using with the sighting relationship. And Stephen, oh, shoot. I would. I do have another slide on, I'm moving out to another room so we don't have to hear that. I tried to turn it off. Yeah, let's see, get my thoughts back here again.
We're talking about the observed data.
Yeah, and I lost my place here. Okay, so yeah, we'll want to use this with the sighting relationship, or the sighting relationship object, and use it for quantitative analysis. And then we have threat actor. And And then also tool is very important because that is can be distinguished from malware. It's legitimate software that has been used by threat actors to perform attacks. And then vulnerability represents some kind of a vulnerability in a system, a network, an endpoint. Now, these are the objects that I've pulled out that are specific for analysts.
Hey, Jane, can I ask a brief question before you go on to,
Sure.
There's a lot of good stuff here. You mentioned Mandiant's indicators of compromise. Has OpenIOC been subsumed as well into STIX, or is that still a separate?
There's actually an OASIS subcommittee called C2 that is working with some of the OpenIOC concepts, and it's really there's really more of a focus on a course of action, on the remediation phase of the whole sort of chain of activity. We're focused more on the front end, that is trying to identify and protect at the front end, and the C2 subcommittee is focused on the back end.
Okay, thanks.
You'll also notice that we have bundle, which was in the STIX 1.x, and we've continued it here. Bundle is a collection of arbitrary STIX objects that are just grouped together to send it over a taxi server. There's no semantic meaning. There's no indication that there's any relationship at all. They're just being sent as a batch group. We have a couple of different objects here. The note, which allows analysts to provide informative text if they're doing research or enriching some sort of a data object as a result of further analysis. They can add informative text, qualify a finding, use words of estimative probability, which I've discussed a lot. There's also the opinion SDO, which is an assessment of the correctness of the information, and this is more of a narrative and more geared toward the analyst, whereas the confidence property is a required property on the STIX domain objects. And Caleb, you'll be interested in that for the confidence property, we've adopted the Admiralty code. So we're looking not only at confidence, but also reliability, and using that kind of standard framework of the Admiralty code. The grouping object is really where we first try to pull together the various objects that appear to be related to one another. So when an analyst is doing work on, say, a threat intel platform, and they're starting to enrich the data, then they can start to take notes and pull together all of the information into a single case, and that case then becomes this grouping. If it is then forwarded on as a more mature STIX data object that has various sub-objects included in it. And then finally, the report object. This is one that the FS-ISAC really pushed for, because what they were finding, the FS-ISAC financial services sector, ISAC, which is really the most mature of all of the different ISACs in the community, they were finding that as they were sending out information, sharing within the broader community, they needed to include not only the granular or atomic level indicators, but they also needed to be able to capture some of the notes and contextual information that the analysts were adding through their enrichment processes. We also have a whole series of meta objects. We have the language meta object, which allows us to translate human languages, like, for example, from English to Japanese, or from Japanese to Chinese. We also have the various data markings categories. The one most widely used is the TLP, or traffic light protocol, and here I'm showing you icons for each of the 4 levels. But I want to point out something very interesting about how we're using TLP, and that is, let me get back in here. We have both a global and a granular mechanism for applying TLP. So when I say global, say I just explained to you about the grouping object. So say I want to apply a TLP marking definition of green to a grouping object, a STIX package or grouping object. But there are a couple of indicators in there that I don't want shared any further than my own internal group. And so I can apply at a granular level a marking definition of TLP amber or TLP red. And so we have a way of very carefully establishing who gets shared what. Now, of course, this is a standards body, so we weren't concerned with implementation. All the various companies that are now out there building product are the ones that are going to be implementing the standard and figuring out how to, actually make that work. But we've provided the capability here. Now, I talked a little bit about the relationship objects, and I have a picture here of an analysis that I did on the TRECA ad fraud a couple of weeks ago. And I just wanted to point out that a lot of the companies are using this graph database mechanism to represent the data. So what you're seeing here is the edge and node type representation of the data. What the center is the report itself, and then all of these various nodes are what would be equivalent to the SciBox objects or the cyber observable objects, and then some of these out here are equivalent to malware and malware analysis. So let me just give you a little bit of a sense of how we're handling both patterning and patterning within the indicator data object and relationships in general. So you see I've made the font very large here for pattern. Indicators contain a pattern that can be used to detect suspicious or malicious cyber activity. And they use the STIX patterning language for specifying the syntax and the content of the patterns. But even before we get to patterning, we also have provided a very nuanced way of establishing relationships. So in the specification, you'll see that we have a table that gives the common properties, the required common properties, the optional common properties, and then any specific properties that are specific to that data object or domain object. We also then have a table underneath that shows how the various domain objects relate to each other. So an indicator can indicate an attack pattern, or it can indicate a campaign, or we weren't very creative in these relationships, but you get my point. And then here are a couple of examples of how we use that. So let's talk about patterning. This is a diagram that shows how the patterning language works. It's an observation expression connected with this observation operator to another or other observation expressions, and then they can also have qualifiers. So there's an example here where we have an IPv4 value, or there's an or statement here, another value that may be followed by a domain name, within a certain amount of time. That's just a very simple expression. But this is intended to do is to give us a kind of a neutral sandbox for how we deal with signature-based systems like Bro and Suricata and Giara. We looked at all of those different patterning languages and realized, because of some of the intellectual property conditions of each of them, we could not incorporate them in whole or in part. And so what we decided to do is develop this sort of layer of abstraction where individual implementations could incorporate their favorite patterning language, like Suricata or Bro. And so that's why we have added the patterning property as a required property to indicator. And you can see here I've gone through and developed these tables that show each of the properties that are specified or given in the specification, whether or not it's a required property, which is indicated with an R here. And these are required common properties. These are optional common properties. And these are indicator specific properties. So for example, for the STIX domain object indicator, then indicator type, pattern type, and valid from are all required. But any of these others are optional. It depends on the implementer. It depends on the producer of the data object. And then, of course, you want to make sure in a sharing community that your consumers can also have the tooling to consume any of the properties that you build into the data objects you're creating. So here we are with observed data. So the definition, observed data conveys information that was observed on systems and networks and makes use of data.
Sorry to interrupt. I realize you're going into a slightly different subject here. Before we go into observed data, on the previous slide, are there any patterns that would work without static atomic indicators? Could we get just a dynamic behavioral signature? In other words, you know, we're not specifying hash addresses, we're not specifying file names, we're not specifying IP addresses. We're just saying something happened and then something else happened within a certain amount of time, and then something else happened. In other words, it's behavioral with action sequences, but no static indicators. Are you capturing that possibility?
What can you give me an example of what?
Yeah. So an example is, and I just use Chris Sanders' example that he uses when he teaches. So the first example is when you do have this static indicator. So a user gets an email message from a particular email address, you know, chris@appliedmsn.com. It's got a PDF attachment with a particular file name, payroll.pdf. The user opens it, it's got a, you know, it's downloaded a file, it's got a hash, et cetera, et cetera. Now, moving to the equivalent without static indicators would be the user receives an email message with a malicious attachment. There's no specific file name. There's no specific email address. They then open an attachment and trigger a download file.
So you're talking about more of a description of what happened, not
these are dynamic behavioral signatures, because anything with static, it doesn't translate across victims, as you know. It can be used to search for other systems that have been compromised within the same victim, but it doesn't scale to other victims because you know, the file name may be changed, the email address may be specific to each target, et cetera, et cetera. So
right, yeah.
You get
No,
the
I
idea?
don't think that STIX can capture that. The way it could capture that is by looking quantitatively at the attack patterns, but STIX is designed to, like grass grows from the ground up.
Yeah.
It's designed to first capture the granular, I won't say static, I'll call it granular, the granular data, the STIX cyber
Right.
observables.
Right.
So that would be the IP addresses and the domain names and the file hashes and the IPv4 and the IPv6 and the network objects and the directory structure, et cetera, all the granular data objects.
So it'll work for Snort and Suricata and any of those rule-based signatures with static indicators, but it won't look at dynamic behavioral patterns. Okay.
Well, you could. I mean, the way that you could do that is by, quantitatively. If you had, 400,000 instances of this same attack pattern that had been happening, but all of the granular data was different, then you could say, well, let's see if there's a correlation with this threat actor.
Okay, so you need to raise it to the next level and look at it statistically, and that's where probably the statistical or machine learning would probably kick in at that point.
Yeah, I would think so. But it's an interesting use case that you described that I don't recall anyone talking about in any of the working sessions.
Okay, thanks.
Yeah, so moving on here to your earlier question about sightings. So there's no top level relationship between the observed data object and other data objects. It has a direct relationship with the sighting STIX relationship object. So what it does is it conveys information that allows us to quantify the number of sightings. So if, for example, in a sharing community, you have 15 different entities that say, yep, I'm seeing that IP, it looks like, we got that phishing email from that IP address, then you're able to capture that kind of information in the sighting data object. And I've seen different implementations of this, how this is being used in the different TIP products that are coming out. Does that answer your question, Stephen?
Yeah, that's good. Yeah, I'm seeing Anomaly using this and Threat Quotient.
Threat Connect uses it.
Yeah, and they use the word sighting for any particular instance of a match between, a SIM event or, a net flow attribute and an external threat feed. So they may be using it slightly differently.
And I think they actually were using it prior to us developing this as a data object.
I think that may be the case as well. So maybe this was, it was a 2.0, a STIX 2.0. So maybe you refined it in 2.1.
We added it. We added the sighting object in 2.0.
Yeah.
So and Anomaly has been a member since the beginning. So Anomaly may be using it in the same way.
Yeah. No, it's good. It's definitely finding its way into the vendor community.
And then here's a little diagram I created that shows that, yes, the number observed is a required property. So you get the first and last observed, which, for those of you that have drilled down into VirusTotal, these can be very important fields when you're trying to do interpretation of, what the malicious activity is. Created and modified refers to when the data object was created. We have this whole sort of ecosystem around, who can and who cannot modify a data object. Only the original producer can modify a data object. If, for example, an entity, a consumer of an indicator sees something else that's significant, they would have to create an entirely new data object and assign it a new identification number, because only the original creator can modify. I've just added a few more. I actually have this same kind of diagram for all of the data objects, but we're limited in time, so I just wanted to give a few more of these examples. I've already mentioned that they're not like bundles, because bundle doesn't convey any context, whereas grouping does. And there's no relationships that are explicit between the grouping object and other STIX objects other than those defined as common relationships. Here's a little relationship diagram that gives you a better sense of, how a particular STIX domain object can relate to SciBox objects or cyber observables. Like in this case, this is an IPv4. Here's a domain name. Here's a URL. Here's an autonomous system. And then here we have a STIX domain object. So these that are blue are the STIX cyber observables. And then this one too. That network object, and then these are STIX domain objects here. So infrastructure delivers malware, or infrastructure has a vulnerability, or infrastructure hosts a tool, or infrastructure is located at. So you can see how you can be very, very expressive with how you're modeling your system. In this case, we show a little poison ivy command and control infrastructure object that consists of this IP address and this IP address, and it also has a link to a malware object that is poison ivy. So those are some of the kind of modeling capabilities that this gives you. Location, you can see that we have targets, located at, originates from. These are all ways to describe relationships with location. Malware analysis, we have it characterizes the antivirus analysis of, the static analysis of, the dynamic analysis of, and then we also have some embedded relationships, where in particular with malware analysis, we wanted to specify what the host virtual machine reference was and the operating system, because those are so critical to understanding what the malware is doing. The note, again, there's no top-level relationships between the note object and other objects, but it does have an embedded object that can point to any STIX object. So if, for example, I want to make a note on some other analyst's discussion of an infrastructure, I can create a note object and make a note on that. Opinion object, again, no top-level relationships, and we have embedded relationships there, and we can point to other STIX objects. So let's just do a little bit deeper dive into the threat actor. This is one of the more complex STIX domain objects. But first, I'll stop here and open it up. Are there any questions at this point? Any comments? Let me just do a time check here. Okay, we've got about 8 minutes. I'm wondering, are you guys good if I go a little bit over, or should I jump ahead to talk about STIX Preferred, the STIX Preferred program?
I'm cool.
You're good. Okay, so I'll go through this pretty quickly, and you'll have a copy of it. So so we've got.
Jump on the hour, but yeah.
Was that Caleb? Do you have to jump off?
Yeah, on the hour. Yep.
Okay, so so let me just touch on this real quickly and then move on to STIX Preferred. So with the threat actor, we have not only the relationships, but we've also drilled down, and then this shows an even more detailed way of showing both the relationships and reverse relationships, which we've written up in the specification. And then I've laid out this table here that shows the required properties, the optional properties, those that are not applicable to this particular STIX domain object, and then some of the threat actor specific properties, the roles, sophistication, resource level, primary motivation level. What we did is we took the Intel Corporation's threat agent library and we adopted many of the features of the TOL and we incorporated into the threat actor SDO by using these open vocabularies. And these are some of the required properties. These are optional properties that have to do with the attack resource level. We have threat actor motivations, optional property, and these can be shown as primary, secondary, and personal. And then we have roles, and these again are all laid out in these open vocabularies that sit at the back of the specification. And then we can also specify how sophisticated we believe the threat actor is if we're doing analysis, and we need to go towards attribution. So this shows all together some of these features that we've pulled into the threat actor. So we want to continue to evolve STIX, and in doing so, we want to make sure that we are addressing the interoperability issue. We want it to be easy to plug and play. We want coordinated actions. What we found with 1.x is that there was too much of a manual interface. And so what we wanted to do was avoid all that. So we decided to establish a self-certification program for STIX 2.0 and 2.1. And we developed these common use cases to drive the demonstration of interoperability. We issued them as what we call committee notes. So they are official documents, but they're not committee specifications. It's a different form that they use in OASIS. And we have a part 1, which relates to interoperability for STIX, and a part 2, which relates to STIX and Taxi for those entities that are developing product in both areas. We've defined a whole series of personas: a data feed provider, a threat intelligence platform, a SIM, a taxi server, a taxi feed, et cetera, et cetera. We have these acronyms for all of those. And then we define kind of how they work among and between each other. This is a great resource. I've given the source here. And then we laid out a set of business use cases that included mandatory tests and optional tests. And this is from the committee note for part 1. So our use cases are indicator sharing and sighting sharing and versioning and data markings, et cetera, et cetera. And this tells which producer personas need to test for that and which respondent or consumer personas need to test for that. Same thing for part 2. We lay it all out. And the objective is to improve the quality of what the products are doing in the marketplace, to make sure everyone knows what to expect, what behaviors to expect, and then we have a checklist at the end of the committee note that shows what test you need to perform. And if you do your self-certification and submit your paperwork to OASIS, you're then given authorization to place these seals on your products or your website or your collateral. So the last 2 slides here are a whole series of resources. I have links to various taxi feeds, free taxi feeds, and other resources. And then I also just want to give a shout out to Brett Jordan for all the STIX icons that I used in this.
Well, that's a wrap. Thanks once again for joining us, and good luck with your STIX 2.1 implementation.